Hello, this is Jonathan, and it's been a while since I last recorded, mostly because, so I just started my vacation, like, last week. So I've been on vacation for a week, but 3 of those days were eaten up because I was doing the Functional Scala workshop with John A. DeGoes. If you don't know him, he seems to be a pretty big name in the functional programming community. I think he and Michael Snoyman will be running LambdaConf 2019 this year, or this coming year. And yeah, the other few days, mostly just recovering because time zone differences and also family obligations because it's getting close to the holiday season here, or well, it kind of is. So yeah, that's pretty much where all my time has gone, but I'm able to record again, which is pretty awesome. And yeah, like, not even that long after I started my vacation, like I think it was like on the first day of my vacation, I went on the Rust subreddit and I noticed that Amethyst had updated. So now I don't have to do all the crazy stuff I was messing around with wherever the heck that was. I don't remember. It was the stuff I was doing with prefabs. I haven't upgraded Amethyst just yet because I wanted to go through that process. Well, I decided that I wanted to get an update out first, since I haven't done one of these video updates in a while. And because normally that's something I do off camera, but after thinking about it some more, I also decided that, you know, it'd be kind of good to document the process for updating dependencies here. So yeah, aside from that, the other big change that came was Rust. What was it? Rust 2018 or Rust Edition 2018? I don't remember what it is, but yeah, a new Rust Edition has been released, which means that there will be breaking changes if I upgrade. One of the bigger new features, though, is non-lexical lifetimes have finally been stabilized. So that other issue I was running into where I had to like rearrange my code. Honestly, the code that I ended up with and turned out to be a lot cleaner anyway. So I think that was that was good that I ended up making that change. But ultimately, I won't be fighting with the borrow checker when more situations like that crop up. So that's really awesome to hear. And yeah, and if you're not sure what non-lexical lifetimes do, essentially, instead of borrows going until the end of the lexical scope, they'll only last until like the last place they were used, if I remember correctly. Also, I believe they're getting rid of like the ref keyword. You're not going to need to extern crate anymore in main. Oh gosh, where's main? Here. Yeah, I'm not going to need to do extern crate explicitly here anymore. That's all going to be gone. Yeah. So a lot of really good stuff is going to be happening soon, and I'm pretty excited for that. So without further ado, I guess we should actually go ahead and upgrade, shouldn't we? Let's go ahead and pull up our CMD here. I'm going to run as administrator just because I don't trust Windows. Oh yeah, the other thing I was looking into was debuggers for Rust. I still don't have a good debugging situation here because I use IntelliJ. So for that last problem that I ran into, that runtime panic from trying to load the prefabs, I was thinking that I could probably debug to fix that, and I went on a bit of an adventure looking around at how debugging is done in Rust. So the first thing I remembered was GDB is supported, or sorry, GDB supports Rust, rather, is how I should phrase that. And so I looked into that. I actually have GDB installed on this system now, and it does support Rust debug symbols. Now the problem is when you use rustup, what rustup does is it decides, hey, let's install the MSVC toolchain by default when you're using Windows, So because I'm on the MSVC tool chain, I can't actually load the debug symbols, so that kind of threw a wrench into the works. I could switch the tool chain, and it wouldn't be that hard. I switched to the GNU tool chain, but like typically you're not going to use GDB on Windows anyway, or at least that's not like a typical use case. More typically, you're going to actually just use WinDBG. Apparently, like I looked around, I wanted to know like what do people use. WinDBG was the first result that came up, and the other one was the Visual Studio debugger. And Visual Studio Debugger seems like a pretty cool option, except for the fact that I'm mostly programming in IntelliJ, and I don't really want to switch to Visual Studio because RLS is, in general, I don't know, I'm used to IntelliJ, and I like the IntelliJ plugin for Rust a lot better. So, yeah, it's, I'm not too interested in using Visual Studio, let's just say. And running two IDEs at once is just, it seems a little bit like overkill. Honestly, I'd rather not have to do that. It's just gonna eat up a lot of resources. Like the lightweight solution in this case would probably be to use WinDBG, but after trying WinDBG, I'm not sure I can even use WinDBG. Maybe I can demonstrate it actually. Let's pull it up. WinDBG. Yeah, so this is what I tried to do with WinDBG. It looks like this. It's yeah, I think it's a pretty old application, I believe. This might be an old version of WinDBG, but I mean, like, look at this thing. Just look at this bloody thing. Like, trying to figure out what to do here. I try to like load like a symbol file path, and it's just like it just did not want to work at all. I just could not make this thing work no matter how hard I tried. So yeah, WinDBG is like the maybe ideal solution, but heck if I know how to use it. I'm gonna have to find like a tutorial on how to use it. Whereas GDB is a lot more straightforward and simple to use, and I can also just run it from the command line. So I'm very, very tempted to switch tool chains, and I might actually do that next time I run into a situation where I feel like I need to debug. But I don't feel like I need to debug right now because the Amethyst gods decided to smile upon me, and they handed me an escape rope here and said, "Here you go. We're gonna give you the next version of Amethyst, so you don't have to define all that boilerplate for your prefabs and mess around with things that could cause them to break." So I'm very thankful for that. That basically just like saved my hide. But yeah, anyway, without further ado, I should run Rust Up Update probably. I'm not sure how this is going to go, but I suppose we'll just have to wait and see. So while we're just waiting for this thing to just, you know, do its thing, I want to talk a little bit about the Scala workshop that I went to. Not because I want to like promote Scala or something here. That's not the point. But because I actually learned a few things from that workshop that are relevant to Rust, and that's kind of what I hoped. I hoped that I would learn like transferable skills between languages from that workshop, not just like, you know, using Scala things or using a specific Scala library, which there was a bit of that too. Like we had to learn how to use Zio and what Zio could do. Zio is a pretty cool library from what I've played with in the workshop. So if I was writing a Scala project in the future, I think I'd definitely consider using Zio. But what I did learn was about using algebraic data types to make your programs more type safe. Now, I've already been doing that, so if you've been following along, in the filler, I've been using like this progression filler result thing. I've been using like the new type pattern and all that. And I had like enums for like the items and locations or whatever. Let me see if I can find them. Yeah, like here. Item, It's an enum or a sum type. So this is stuff that I already knew about. The one thing I didn't know about, though, wow, that was kind of weird. I guess it's because it's running Rust up in the background here. Yeah, that's going to be affecting the IDE. Yeah, the one thing I didn't know about, though, was ways of avoiding runtime errors. By the way, these panics are awful, and I really, really should get rid of them at some point. I know I was like, yeah, you know what, maybe I'm okay with panics before, but yeah, no, panics, they're definitely bad. I don't want to panic here at all. I should be returning a result instead. But anyway, the one thing I learned about was a smart constructor pattern. And a smart constructor pattern allows me to avoid doing stuff like this. Yeah. So instead of getting doing this runtime check to validate my input here, what I should have done was constructed my data in such a way that I never even had an invalid input. Now, when you're playing with vectors like this, obviously that's pretty hard. I mean, I didn't create vector, obviously, but I could create a wrapper around vector or vectors. In this case, I'd want to create like a wrapper around like 2 vectors, so just to verify they're the same length. And then I could have a smart constructor that says, well, you can only construct this I guess product of these 2 vectors if they are the same length. And I could also make sure that you can't like mutate the product so that you can't mutate the terms of the product, so you wouldn't be able to actually, you know, break any of those invariants. This is actually something that is expressed a lot more simply and cleanly in Scala, but it's definitely doable in Rust. There's other things that Rust does a lot better than Scala, so I think it's a fair trade-off. But yeah, it's definitely something that I should look into doing here. So in the case that you do construct the product with 2 vectors of the same length, the product will say, okay, now we return a sum. And by sum, I don't mean SUM, I mean SOME, a sum, like as an option of that product. And if I decided, oh, I don't want to return anything for, you know, 2 vectors that are not the same length, then instead of returning a sum, I would return a none. Which I guess that's like the obvious thing to do, but in this case we're trying to make sure that our function is total, and yeah, we don't have any like runtime errors. We want to make sure that this check happens when you're like constructing the object, so you'll never construct an object with invalid state. Or it's at least handled at compile time, you know. So if we ban invalid state, then we don't need to worry about checking stuff all over the place. We only need to handle the sum none, and that all has to happen at compile time. So yeah, that's what I learned. It's not the only thing I learned. I also learned about using generics. So the functions that I've been implementing, I haven't very heavily used generics because, well, mostly I wasn't really comfortable with generics. I also didn't really realize that making your functions polymorphic actually restricted the number of implementations you could make for your function. Like your function implementation can only be one of like so many different options when you use generics, because when you're using a generic, it's universally quantified, so it has to work for like all types. And I mean, I always thought that, you know, maybe you should like restrict the generic so it only works for, I don't know, certain types. And I mean, you can do that with like trait bounds, like, this type has to implement. It works for all types that implement whatever, like ORD or equality. But yeah, it turns out just having that universal quantification, it allows you to restrict. Like if you look at a function with signature int to int, like there's so many different implementations of that. Like it could just be a constant 0 or a constant 1, constant 2. You could take the integer, you could multiply it by 2 and return that as a result. You could like take the integer, add 1 to it. It's like an infinite number of possibilities. But if you had like a universally quantified type parameter that for some function that takes, you know, some a and returns an a, then you pretty much know that, well, if it has to work for every type, there's not really much I can do with this. I can't really assume anything about it. I can't like add it. I can't try and concatenate stuff to it. Like, I don't know if it's a string. I don't know if it's a list. I don't know if it's anything like a int or whatever. Like, I don't know the specific type. So in that case, like, aside from side effects, the only thing I can do is return the value that was given. And so we can pretty much say for sure that that's an identity function, as long as we obey, you know, the laws of like pure functions, or I guess rules. So yeah, that's those are the things that I learned. It turns out that making functions more polymorphic, well, at least supposedly, it makes things easier to implement as well, because of the restricted number of possibilities for the implementation. I can kind of see that, but yeah, I haven't really put it into practice just yet, because, you know, I've been busy. I have other things to do with my life during this season. So yeah, that pretty much covers everything from that course that's really like relevant to Rust. I mean, we'd also covered type classes, and of course Rust has type classes in the form of traits, but traits are a lot cleaner than Scala's type classes. I guess actually there's one thing I learned about Scala type classes, is that you can kind of, at least the style that John A. DeGoes uses is he decides to add laws to his type classes, and like that's like a fundamental thing that you have to check, is that any instance of a type class obeys those laws, and there's no way of really enforcing that. So you could add like a unit test to check for that. But like, yeah, the law would be like a method or function on the type class that simply returns a boolean and and it will enforce some rule, like, I don't know, like associativity, for example. And it'll return false if it doesn't work and true if it does. You don't see that in most type class implementations. I don't think that the Haskell type class has like the laws like directly encoded like that. I mean, it might in the actual implementation. I don't know. I don't really know Haskell that well. But it is certainly possible, from what I've seen, to implement things like functor for something like a set, even though a set is not a functor. Like, a set can be mapped. You can create a map function for a set, but mapping a set to another set might not preserve structure, because, well, sets are, you know, the elements of a set have to be distinct, so everything might collapse into, you know, one value or something. Like, it won't obey the laws, the functor laws. So a set is not a functor, and having laws to enforce that is important. So yeah, it might be possible to just add such laws in Rust as well to traits, but yeah, since they aren't that easily enforced anyway, I'm not really sure if I'm gonna do that. Yeah, just thinking about it, I'm not 100% on, you know, do I want to add like an extra method to each of my traits or type classes that, you know, check some kind of law. It could be worthwhile, certainly. And yeah, I can understand how it would make the program safer, but yeah, it's something that would have to be encoded as a unit test. Or at least enforced through unit tests. Let me think. Anything else? Yeah, we went into higher kind of types, of course. It's kind of old hat. For me, anyway. And as we all know, Rust doesn't support HKTs, or at least it doesn't support like HKTs in general. So we can't have things like functors and monad type classes anyway. So that's kind of irrelevant to Rust. The program metaphor, like the whole like reification of programs, or like bringing programs to the value level, or making them first class citizens, I guess. I don't know, is that what you call them? I forget what the actual term is, but it's like first class values or something. Anyway, you basically convert your programs into values, and that's how you can create like pure code. And but when you actually interpret the program, then you have to use impure code, and so that's how you write like purely functional code. Yeah, I thought that was a pretty cool way of looking at things, because I had never seen that before. Like, I understood how like monadic do comprehensions worked with like flat map and stuff, but yeah, I never really made that kind of connection. So yeah, that was really cool. We also learned about parallelizing programs using like ZO. ZO has a lot of good utilities for that, parallelizing programs that are pure, and what kind of guarantees you get, and how it makes parallelization super easy. Like the parallel version of the crawl that we implemented, just like add 3 letters, par, and voila, everything is fixed. It's all parallel now. I thought that was super cool. Yeah, that's definitely more of a ZO specific thing, and in Rust that, yeah, it just doesn't exist. So yeah, not really relevant to Rust there. Speaking of monadic do notation, yeah, there are some cases in Rust where you might want something like that. I did remember that. That's definitely, yeah, something that I realized. And Rust kind of takes the C# approach, actually. So C#, if you're not familiar, C# doesn't support HKTs. They don't support like the monads or applicatives, but it still supports like certain I guess God, the C# effect system has a way of sort of emulating like monadic do notation first in very special cases, and Rust takes the same approach. These question mark operators, yeah, these basically do the same thing as monadic do if you have like a whole bunch of them, because it'll return a value. Otherwise, if it's like none or a result error, it'll like fail out, and then it's almost like a try catch even. You'll like try this, and if it fails, then you'll do an early return with the none or the error. So yeah, it turns out that that's pretty much exactly the same as what you would do with a monad comprehension. Yeah, thinking about it, I'm not sure. Like, I'm not sure that's how you'd do it with like an applicative, because applicatives don't require they're not dependent on like some kind of previous value. So yeah, so this is like Rust's way of doing monadic do notation, or like it's Rust's answer to monadic do notation. And what's kind of nice about this is that it also allows you to play with like, you can also throw in other statements in here that like maybe perform side effects or whatever. Not that you necessarily want to use side effects, but still, it gives you options with this notation. On the flip side, it's also a special case, and Rust had to add special syntax for a special case rather than being able to just abstract over all monads and just have monadic do notation. So there are downsides as well. But yeah, monadic do notation is definitely more appropriate when you don't want to allow things like side effects, or if you don't allow things like side effects at all. Then yeah, it's definitely a much better option if you can afford to do that. The other special case that Rust has, that I'm aware of at least, is for futures, which are coming soon, I believe. It's async await syntax, similar to what C# has and what JavaScript has with its promises. Rust has futures right now, but you end up with like a rightward drift problem, as people know. And the solution to that rightward drift problem is, of course, monadic do, or async await in that case. So it allows you to kind of like reason with with like asynchronous computations in this serial way by, well, basically doing something like this, except I think it's just like await in front of the operation that you want to do next. So yeah, it is basically the same thing as monadic do, and it is the same approach that C# takes. So that's cool. It works. It's definitely going to be like less scalable overall, I would say, but considering that Rust doesn't aim to be like completely pure or anything like that, like we're not trying to reify programs here or anything. Although I guess you could technically argue that like option and never mind. Let's not get into that. But yeah, this is stuff that I've learned recently, and I just thought it was cool, and I want to share while we wait for things to happen. Hello. This Rust update's taking a really long time. Well, it says that this is updated, but it's not like it's going back to the console. Hello? Are you okay? I'm gonna leave it running for a bit, because I'm not entirely sure what's going on. But yeah, I don't really have much else to say. So let's go look at our cargo file. So yeah, Amethyst updated. I think it's at 0.10 now. I want to verify that though. Yes, it is 0.10. It feels weird to say 0.10 because, you know, it's not really. It's not that, you know, it's in math that would just be like 0.1. But this is In fact, I don't even know if that's the right way to pronounce that. I don't know if you'd pronounce this as 0.10.0. Like, but that's the way that I'm reading it. That's the way my brain reads it, and that's the first thing that pops into my head, so that's why I say things stupid like that. Yeah, okay. So they removed lifetime from simple state. Okay, I don't really care about that, though. They made it really simple. Prefab data can now be derived for many situations. Yes! Yes! That makes me very happy. Ooh, get default font. Okay. That could be useful. I'm not sure what else is going to change with all this. I mean, well, I'm looking at the changelog, so I guess I do know, but I don't know what in my code is going to have to change as a result of upgrading. I definitely want to upgrade because of the prefabs, for sure. That's going to make this super awesome. Oh, and you can hide entities with the hidden field. Oh, that's awesome. Huh. So rather than deleting entities, I can just hide them now. And I think that's probably what I will want to do. Yeah, it seems definitely like a good change. I'm very excited about that. Cool. So, I guess, yeah, we got an update. I also now have a better understanding of what lock files do. I think this update isn't going to be reflected immediately. I'm going to have to do like a cargo update to update the lock file so that it doesn't, yeah, so there aren't any problems. But what I've learned about lock files is they allow you to like lock down your dependencies so that they don't like update too eagerly and get the newest versions as soon as they come out or anything like that, because that can lead to certain security vulnerabilities. Yeah, I think NPM had an attack not too long ago, just the other week, where someone injected some malicious code in some minified JS and committed that to some big project, some NPM package, and everyone got, well, everyone who downloaded like a certain version got like this, you know, malicious code on their system. So yeah, I also understand package managers a little bit better now, and I think that's got a lot of people who are at least working in that area of like package managers thinking about solutions for how can we prevent this kind of attack from happening again. And it's a lot of interesting solutions I'm seeing cropping up, but yeah, it's certainly a rather new initiative. So I guess we'll see what happens. Well, this thing is never gonna finish, is it? Oh no! Cargo project update failed. Roro. Access is denied. Are you kidding me? Oh, I'm pretty sure access is denied because of this. Okay. Well, in that case, I'm not really sure what to do. I think what I'm going to do right now is probably just stop recording. Yeah, I think that makes sense. I'm going to stop recording. I've said what I want to say. I've given my update. I'm basically just going to continue with this. This will finish at some point, eventually, maybe, hopefully. And I'll update my dependencies here, and yeah, we're going to try and get the prefabs working with the new derive.